this is the last thing we need to learn before you have learned everything you need to know. So for this, function notation is a lot like evaluating, but it looks different. Because instead of just given equations, really we were given expressions before, now we're going to be given equations, but they won't be written in y equals, they'll be written in f of x equals. So when you read that, it's f of x. F of x is the same thing as y. F of x is more for functions, y equals is more for equations, but they're really the same thing. With functions, you're doing more input-output things. Equations, you're more graphing, solving, but they're really the same thing, just in different formats. So when we evaluate something with f of x, we're going to substitute the value in for x for these examples. So if we have, like, in number 1, we're given this equation, this function, and we have f of 5. Well, because this was f of x, I'm going to take 5 and put it in for all your x's. When you do that, the f of 5 doesn't really do anything. You're just saying you put 5 in for x. You don't do anything else with that. Then you just simplify this one. So what would f of 5 be? 12. So my final answer, I can leave it like this. F of 5 is 12. That's me saying when x is 5, my y value is 12. Or I could write it as f of x equals 12. My y value is 12. Either one is acceptable. Questions on that? So then do this, we're going to do the same thing for b. What would f of -1 be? 6. And then do the same thing for -3. What would that be? 4. So f of -3 equals 4. Do you have any questions on how we evaluate using function notation so far? Look at numbers 2 through 6 on this page. Which of those do you want to see, do, go over, have questions about? Great, so with these, you could still do these by hand. You could also use your calculator. Class does most. For this first one, it's going to be, I'm just going to put equals in parentheses, -4 outside the parentheses squared minus parentheses -4. And in your calculator, you could do one of two things, or in decimals, you could do one of two things. In your, you could just type it in as is. And get the answer that way. If you have multiple that you need to find, you could keep changing the number, or you could put that into your y equals as the original function, x squared minus x. Go into my table, and I was looking for -4. And for this purpose, I just want to set it up, but then I can say f of -4 equals 20. Again, set this up, but then I can figure out what the answer is. F of -1 would be 2. And then set up that last one and then figure out what that is. So I'll set this up and I want you guys to figure out what that is. So you can either put them just in parentheses or you can go into the white equals. So if you're given f of x or f of some number, you're looking for y, and then you find that y value. Questions on 4? Either using parentheses or using the calculator, go ahead and find a, b, and c for 6, and I'll just set each one up if you're using it. What is f of -3? -31, is that what we all got? Yes. F of -1? -4, is that what we all got? Did we all get -4? It should be -1 -6 -4, so yes, -11. And then f of 5. Do you have any questions on how we find the y value when given the x value? It's just the same thing, but with f of x. Alright, look on the back.
Thank you.
7 through 10 are more examples. Are there any of those we want to see or do or go over before we talk about the others?
Okay.
In 10, we're doing the same thing. It's now just absolute value. So we'll have g of 4 equals the absolute value of 4 minus 4 squared. And then the same thing for the rest of these. So G is the same thing as F, which is the same thing as H. The variable in the front might change. You might see J, K, it's the same thing. G of 4, remember at the end, if you put this all into your calculator at once, it'll give you the correct answer. But if you're doing it step by step, that would be 4 minus 16, negative 12, then you would take the absolute value of negative 3. Alpha window, and that first one. So I said what this one was. G of 4 would give us a positive 12. All of these answers are going to be positive. If we had a negative outside the absolute value, then it could be negative, but all of these should be positive. Would G of negative 7 be?
Oh, yeah.
And then G of negative 3. Should be 12. Okay. In 11, it's really doing the same thing. There's this word problem attached to it. So in this, anthropologists use the length of certain bones of a human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x. The function h of x equals 61.41 plus 2.32x can be used. So they gave us the function. Now they're telling us to find h of 46. So just like before, put 46 in for x. Part B asks, what does this mean? So in the context of the problem, since we're talking about length of bones and height, what would these two numbers represent? Which number would represent that? 46 would represent the length of the bone. Yeah, the length of the femur, yes. It does in centimeters of height. I don't know what this is in, but 46. Which means the 168.13 is what? For height in centimeters. And if you wanted to convert that, you could, but we don't need to do all that. So you may get questions where you have to, based on the problem, identify what this means. you may see something like a graph. And this, you're doing the same thing, but on a graph. So for part A, we're looking for f of negative 4. So this function is our equation, is our y. We're looking at when x is negative 4, what is your y value? You would find when x is negative 4 and find what your y value is, which would be So what is f of 0? 0. F of 2. Negative 2. And then f of 5. Negative 1. So it's just finding wherever this is on the graph. Questions about that? Go on to the next page. So here it's really the same thing we've been doing, but now they give you multiple numbers, which means you have multiple answers. This is really where your table would come into play. You could put this into your table, into your y equals, and then find these 3 values in your table, so that when we're looking for the range, we can find those 3 values. So go in, type in, what was that, x minus 5. Go into the table and then find those 3 values, when x is 4, when x is 6, and when x is 8. So at 4, negative 1, at 6, 1, at 8, 3. Negative 1, 1. It would be the same process. And you would write that in order, least to greatest, in curly brackets, just as the domain is given. You may also be able to type in the f of x here and not need it. So that will just give you the line, but you could change it to the table and then put in whatever values you need. Or you could just type in, you don't need the f of x. Again, it's going to give you that line. Again, you could change it to the table and add in whatever values you need. So either or. Look at numbers 8 through 12. If there are any others we want to see, do go over, have questions about. So go ahead and put that into your calculator in your y equals, and I want you to tell me the range for values negative 12, negative 6, and 30. calculator helps you just do this faster. You could do this by hand also, just 3 different times or 4 different times, depending on what it is. Do we have any questions there? We're going to start the next page, but not get very far because we'll finish that Monday. But go on to the next page. It's going to look very similar to the beginning. So we don't need to redo this part. But this part is different. Because previously we were substituting some value into x and finding y. But now these are saying f of x equals, which means we now have y and have to find x. So you have to know which one you're looking for when you see that. So if you see f of x, this is your y, and we have to go back and find x, which means we're going to put this in place of this. What I would do is just rewrite this as y equals, put that value in where y is, and then solve for x. And we would do that by subtracting 7 on both sides. So that x equals -12. So we're really just doing the opposite of what we were just doing. We'll do the same thing for b. This is already y equals, so I don't have to do that again. I'm just going to replace the -5 with 0. And then all of these are going to do the same movement for x. To solve for x, subtract 7. So when y is 0, what is your x value? -7. And then when y is 10, what is your x value? 40. So if you wanted to double check yourself, you could put this back in here and see does that give you the y value, and vice versa. You could also do this in the table. But remember that you're given your y value, so you have to look at these specific y values. When y is -5, you may just have to keep going until you see that. And then when y is 0, and then when y is 10. So you may just have to scroll until you find those, but you can use the table also. You cannot, it becomes a guessing game on Desmos. Not that you can't do it, but it becomes a guessing game. So if I have this and I change it to a table, I need to find when y is, let's say, 0. Right now I see these are going up and these are going up. So if I go backwards, maybe I try like -5. Okay, not there yet. Maybe I try like -10. Oh, so I couldn't do. Okay, that's too far. Somewhere between -5 and -10. Close. So it becomes a guessing game. You can do it, but you just have to remember what you're looking for, because you can't put in y values and get x values on this one. Questions there? Okay, we're going to do more of those examples on Monday. For the next 15 or so minutes, you guys have Delta Maths that are due today, your radical operations and relations and functions. You could be working on the 8-ball packet, the MathGap SL packet from before, your test nav that's due on Monday, practice quizzes, previous Delta Math, work on